So in section 6.6, we learned for the first time how to do what we call mass-to-mass calculations. And this is by far the most common calculation that we do in general chemistry. So this type of calculation is often referred to as a grams of A to grams of B calculation. And the nice thing about this type of calculation is that it always involves the same set of conversion factors. In order to move from grams of one substance to grams of another, we're going to first convert to the moles of the first substance, then we're going to convert to moles of the second substance, and then finally we'll convert to grams of that second substance. And to do this, we'll multiply by 1 on the molar mass of our first substance, then we'll multiply by the appropriate mole ratio, and then finally we multiply by our molar mass of our second substance. So it always has the same 3 sets of conversion factors, so it's kind of pretty straightforward once you get it dialed in. Now, it is really important that you get this type of calculation, down pat, that you get really strong at being able to do it, almost sort of like on autopilot, because we're going to be doing it again and again and again throughout the general chemistry sequence. So the key thing is that we're going to be using the mole ratio between the two things that we're trying to relate, along with the molar masses of the two things that we are trying to interrelate. So if we have this, say it's a reactant and a product, if we have the molar mass of the reactant, the molar mass of the product, and the mole ratio, the calculation becomes fairly straightforward. So let me give you an example. It says if 28 grams of methane is reacted with oxygen, how many grams of water is produced? So we recognize that we're going from grams of methane to grams of water. So this is a classic grams of A to grams of B. So the first thing we need is the balanced chemical equation, which if you're lucky is given to you. And what we're told is that we've got 28 grams of methane and we're trying to figure out how many grams of water that we have. So we know that we need the mole ratio relating methane and water, and we also need the molar masses of methane and water. And we'll put all of that together. We're just going to follow that scheme that I illustrated in the title slide to solve the problem. So we want to calculate for the mass of the water, that's our B, and we're going to begin with the mass of the methane. So methane is our substance A. So we've got 28 grams of methane, and we know that 1 mole of methane weighs 16.05 grams. And how we're getting that is this is just 1 on the molar mass of methane. So that eliminates grams of methane. I've just turned my grams of methane into moles of methane. What I'm going to do now is use my mole ratio, and for my balanced chemical equation I know that I get 2 moles of water for every 1 mole of methane. So moles of water will cancel out, leaving me moles of methane will cancel out, leaving me with moles of water. So my second conversion factor gets me 2 moles of water. Now finally what I need to do is multiply by the molar mass of water to turn my moles of water into the grams of water as required. So multiplying by the molar mass is 18.02 because I've got 2 hydrogen atoms and 1 oxygen atom. And what that leaves me with is grams of water. Okay, and there I go, give my answer, in this case, to 3 significant figures in agreement with the data that was given. So it's fairly straightforward. I multiply by 1 on the molar mass of what I was given, then I multiply by the appropriate mole ratio, and then finally I multiply by the molar mass of what I would like. So it looks like this, right? I'm given some grams of substance A, I multiply by 1 on the molar mass of A, and that gives me moles of A. I then multiply by the mole ratio that relates A and B, and so that needs to have the moles of B over the moles of A, and that'll convert my moles of A into moles of B. And then finally, to get my grams of B, I multiply by the molar mass of substance B. As I mentioned right at the very beginning, this so-called grams of A to grams of B type conversion always involves those 3 conversion factors: 2 molar masses and the mole ratio relating those 2 substances. So it's not that difficult. You just kind of got to get into the habit of doing it. If you insert the units into your calculation and cancel them out every time, it'll make certain that you're not getting any errors. Okay, so here's one where we're going to begin with a product and work our way back to a reactant. So we have our balanced chemical equation. We saw one like this earlier, and it says if I want to make 15.2 grams of iron 3 oxide, how many grams, and I have to be careful to pay attention to my units here, of oxygen are required. So we can see we're going from grams of O2 from grams of Fe2O3. So this is definitely a grams of A to grams of B. Fe2O3 is going to be my A, grams of O2 is going to be my B, what I'm trying to solve for. So I know I need the molar mass of Fe2O3, I need the molar mass of O2, and I also need the mole ratio relating the two. So I'm going to take my grams of Fe2O3, multiply it by 1 on the molar mass of Fe2O3, and when I cancel units, you will see that this leaves me with moles of Fe2O3. So what I've got to do now is look at my coefficients and get the appropriate mole ratio. And I can see here that I get 3 moles of O2 for every 2 moles of Fe2O3. So I want to turn my moles of Fe2O3 into moles of O2. So I multiply it by my mole ratio, making sure I've got moles of Fe2O3 on the bottom so that they cancel out. And that leaves me with moles of O2. So I'm 2/3 of the way through. The final step is to turn my moles of O2 into grams of O2. And to do that, I'm going to multiply by my molar mass. So remember, I've got 2 oxygen atoms here. So 2 times 16 grams per 1 mole of O2, and it ends up that I get 4.57 grams of O2. And I know I'm right because all my units cancel out, leaving only grams of O2. So how did it go? It went grams of A times 1 on the molar mass of A times by the number of B's over the number of A's times by the molar mass of B every single time, and then that will give you the grams of B. It's really that easy. So that's what we did, right? Grams of A multiplied by 1 on the molar mass of A multiplied by the number of B's over the number of A's multiplied by the molar mass of B gives you the grams of B. So you've just got to be able to put 4 numbers into your calculator and hit enter. Okay, so that concludes this section on how to perform the mass-to-mass problem that we typically see in general chemistry.